Professor Dr. Mehrdad HEJAZI from University of Isfahan, and his topic will be about earthen built heritage in Iran. Professor Mehrdad, the floor is yours now.
Şimdi ikinci davetli konuşmacımız olan doçent doktor Mehrdad HEJAZI'yi davet ediyoruz. Kendisi İran'dan, İsfahan Üniversitesi'nden katılıyor ve konusu da ekranda görmüş olduğunuz gibi İran'daki kerpiç, toprak, mimari miras. Bunun hakkında bahsedecek. Doktor HEJAZI, söz sizin.
Thank you very much. I hope you can hear me.
Yes, we can.
Yes, we can.
Okay. First, I should thank Fatih Sultan University, Professor Bilge, and also Professor Dabandi for inviting me to present a lecture about heritage earthen buildings in Iran. In my speech, I would try to introduce Iranian earthen architecture in a very general form. My intention is to make the audience familiar with the tradition of Adobe Making in Iran. Therefore, I give you an introduction first, and I will give some comments on Adobe Making in Iran. Then I will concentrate on construction technology, and then I will go to characterization of Adobe in Iran, and also the elements of sustainability and damage to Adobe and its protection, and at the end I will conclude. Well, you know, the country of Iran, which is neighbor to Turkey, and as we have had similar culture for many centuries, the situation is similar in many parts. In Iran, we have lots of clay, we have lots of soil, and therefore the use of sun-dried mud or adobe has been in use since the 6th millennium BC. For example, if you have a look at the Bam Citadel, which is one of the greatest adobe or earthen complexes in the world, you can see that the citadel has a history of more than 2,000 years. It means that it has been a long history in Iran to make adobe and earthen architecture. And also, when we go to central Iran, we have the city of Yazd. And recently, a few years ago, its historical part has been registered as a World Heritage Site. It means that it's very important in the country, and even if you go inside the Adobe part, the historical part, you can have a feeling of a few centuries ago. You can just walk there and experience an interesting atmosphere. Well, as Professor Bilge explained before my speech, the making of Adobe should be similar in everywhere. In Iran, it's the same. We add or we mix clay with soil and sometimes with straw. And as you can see, we put water inside for a few days in order to start its chemical composition. Then after leaving the mixture for a few days, they mix it, then they mold it by hand and then place it vertically for drying. As you can see, there are some wooden molds that the mixture is put inside with hand pressure, and then after 1 or 2 days that would be put vertically in order to be dry. Here you can see it's a real life in the BAM Citadel. As you can see, they add the components, then they add water for a few days, and then, as you can see, after that they mix it. Usually they mix it by foot, and when it is the volume is not so much, they use hand to mix it, and then they put it into a mold, as you can see, and after 1 or 2 days, when it is somehow dried, then put it like this, and then they make a deposit of it, and they can use it for the restoration works or construction works. Here you see a movie. I have taken this movie in 2007 when the BAM Citadel was under restoration. As you can see, it's the real life. Still, they use the same method because in Iran they decided not to go for technical or mechanical procedures for making Adobe, because we think that traditional method of making Adobe is itself an intangible heritage, and we are not going to change this tradition. Again, here you can see how the soil is mixed by hand, and then they put it in mold. And those who have such experience know that you need 4 or 5 years of experience to make such a good molds and make such a good Adobe breaks. And as you see, these people make money from this job. It's their job for many centuries. To make or to construct an Adobe building, first we need the foundation. As you see, the foundation is made of lime wash, made of sand. As you can see here, we have foundation, gravel, and sand with lime, and then we have a dado, and here is the traditional way. In Iran, we never use the concrete or reinforced concrete for Adobe buildings. Instead, we use lime concrete. As you can see here in the picture to the right, at the bottom type, you have the dado, and also you have the foundation, which is not seen here. And also, when you go to another city in Iran, to Abiyan, as you see here, again you have the stone dado, and in different parts of the country, the same method is used. Then we have the wall on the top of the foundation. Usually they use vertical wooden posts, and at the top of the wall they use a horizontal beam, and then they add additional beams. As you can see, this wooden tie beam has an important role in controlling the displacements. As you can see here, this is in the picture to the left. It's a wall which is constructed by Masterman in the BAM Citadel, as you can see, and this is the reality how they make it. In order to align the angles, they use a simple way, which is this instrument that they use. They use a simple rope, and this is the clay mortar, and here Adobe blocks, Adobe bricks. They put it in water for a few seconds before putting on mortar. And that's it. It's all made of clay, all made of soil. This is the master builder, and the others are disciples. After a few years, between at least 10 years, then they can start the work that the master builder does at the moment. As you can see, this is the tradition, and we in Iran try to keep this tradition, and it's very important that when tourists come to the citadel and at the same time the construction or restoration work is going on, they can have the feeling of many centuries ago how they used to build the citadel. Then on the top of the wall, for the entrance or for the door or for the window, we have the lintel. And as you can see here, the lintel is usually arch lintel, which is made of adobe. And for making it, you need some sort of shoring. Sometimes this lintel could be straight, but when it is straight, it is usually made of wood. Then you have the floor, where you want to sit or you want to live. There are two different types of floor. The first one to the left is made of lime concrete. As you can see here, it's a stone set in lime mortar. Then you have lime paste, and on the top you have mud straw mix. Sometimes you put also adobe brick here. The other method is a wooden floor. When you are afraid of moisture, then you make a distance between the ground and the floor for say 40 or 60 centimeters. Then you use wooden beams, and on the top of the wooden beams you have lath, and on the lath again you will have mud straw. These are two different types of making the floor. Well, sometimes instead of using adobe bricks, you use rammed earth or Pisé, in which in Iran we call it Chiney. As you can see, it is usually used for unimportant walls or unload-bearing walls. If they want to separate the spaces usually, or if they want to protect the whole area, they make a large rammed earth wall. As you can see here, it's similar in every part of the world. Usually you have some sort of framework which is wooden. Then they put soil. You compact it, and every 1 meter, as you can see here, they put some horizontal elements, which could be adobe bricks, or it could be some wooden branches, in order to prevent from total cracking of the wall. As you can see here, this wall has been destructed during the earthquake in 2003 in Bam, but the whole wall is not constructed. It has kept its stability. As I explained here, when you have large gardens in Bam, they protect the garden by this type of walls. Then we go for the roof. For the roof, there are two different types. If you want to have a flat roof, you have to use a wooden roof. But when you want to have curved roof, then you can use adobe, as I'm going to explain. First, we go for wooden roof. as you can see here. As I explained before, when after the wall are finished, then you put a tie wooden beam and then secondary beams and laths and so on. And then you have the product as to the picture to the right, as you can see here. The picture to the right is made in 4 centuries ago in Isfahan, as you can see the situation. As I explained, this is the method that they use, and as you know, this roof acts as an rigid diaphragm, which prevents the walls from different displacements, and therefore they give integrity to the whole building. And at the same time, it's not heavy; it's a light one, and at the same time, it acts as an insulation for the heat or for the cool during the summer or during the winter time. Well, sometimes you need to have Adobe roofs or curved roofs. There are so many types of roofs. They could be spherical, quadripartite, groined quadripartite, barrel, or it could be ribbed, or so many other vaults. For spherical vault, as you know, it's very simple. You start first. You start or you construct two corners. After they reach each other, then you have a circle, and on the circle you put the Adobe breaks until the spherical vault is completed. Or sometimes you go for quadripartite vault, as you can see here. Its construction is very difficult, but the picture to the right, it is a new one built in BAM Citadel after it was deconstructed. And as you can see, it is very precisely constructed, and this is the one which is used mostly in BAM Citadel. Sometimes you use another type of vault which we call the groined quadripartite, like this one. The one to the left is again constructed in BAM Citadel, and this is the other type of the vault which could be constructed by Adobe. And a very similar and very general vault is the barrel vault, as you can see here. And there are so many barrel vaults in most of the buildings, as well as to the BAM Citadel, as you can see to the picture to the right. And this is the method of making a barrel vault, because we are not using a framework, a shoring. It should be constructed based on its own weight. As you can see here, first you put a gypsum framework, then you put the first layer of the Adobe, and you are inclined. And when it is come like this, then you can continue to finish the work, as you can see. And it's the same. It's the same in all countries in the world. And in order to adjust to keep the shape, they use adjusting ropes, a very simple method which is used for construction. And then we go for ribbed vault, as you can see here. We have a vault, and then we have 4 ribs around. The one to the right is the one which is damaged because of the earthquake in the BAM Citadel. But as you can see, it has kept its stability. It means that it has a very good stability during or due to loading. And one of the main parameters is the rib itself. In order to make the rib, as you can see here, it's a technique. You need a shoring. The shoring is usually like this. It's a gypsum one. It's a gypsum. Framework, as you can see here. And for constructing the rib or the form of the rib, they do it on the ground. It means that they draw the shape of the arch that they need, and then they put some breaks around, and then, as you can see, and here you have a space in order to put some sort of wooden elements, and then you pour or use gypsum mortar until it dries. And when it is finished, you have it. It's like this. And as you can see, this is one of the gypsum forms after the earthquake. And here, as you can see again, you have 1, 2, 3, 4, or here 1, 2, 3, 4 of this gypsum, and then between these forms or under these forms, they put the Adobe bricks, as you can see in the left-hand side picture. And here, as you can see, this is the product after the construction. Here you can see how they make it. The shape of the form of the arc is drawn on the ground. These breaks are used to make the space. These are gypsum, and these are the wooden elements. And as you can see, it's in the summertime. It means that gypsum settles very quickly. Also, they use some sort of natural ropes inside the gypsum. And this is the product, as you can see. But let's see how they do it. As you can see, they are putting the wooden elements inside the gypsum mortar, and the other person would bring some more gypsum mortar from other side. As you can see, all things are by hand, no mechanical system. In the BAM, we kept this tradition, as you can see, and that's it. The tradition since at least 2,000 or 3,000 years ago. Well, these are the structural characteristics of Persian Adobe or Earthen structures. But let's go to elements of sustainability, which is common in all countries. It doesn't matter it's in Iran or Turkey or Peru, everything is the same. The most important element, sustainability element about earthen structure or earthen materials is its high thermal capacity. It means that during the summertime when sun shines, it takes a few hours, at least 6 hours, to that the heat of the sun transfers from outside to inside, which is very good. After 6 hours, we are already in the late afternoon, and it doesn't matter if inside becomes a bit warm. Then, if you are in the desert, during the night, even in the summertime, it's cool. It means that during night, which is cool, then you have the heat of the heat which is embedded inside the material, inside the space. It means that you will have the sunshine heat during the night. During the night, outside is cool or cold. Then the cool is getting inside to the Adobe wall, which is about 60 to 100 centimeters thick. Again, it takes 6 hours for the cool to be transferred inside. And then it is already the morning. And then we go towards the noon. And then we use the cool of the previous night. It means it has very high thermal capacity, and it's very, very important. At the same time, the architectural design is very important. The whole city is compact, as you can see. This is an aerial photo of the historical part of Yazd, as you can see. This is a photo from another city near Yazd, in Earthen. As you can see, everything is compact. Even if you come outside of the house, the picture to the right, you can see even the passageways are very compact. And if you are during the summertime, the sunshine is prevented with these elements. The other thing is you have minimum exposure of surface to the sun. As you can see here to the on the picture to the left, it is the summertime and it is around noon or afternoon. As you can see, half the buildings is in shadow, which is very important. And even in the picture to the right, when you have domical roofs and sun shines, again, about half the roof is in shadow because of the domical roof. And it means that the architectural design also help the sustainability of the building. And in the other hand, as you can see, the color of the surfaces is light, and when it is light, it can reflect the sunshine during the hot or warm times. In traditional houses, or even in traditional other buildings, usually you have a central courtyard with a pound of water and gardens around. And therefore, it makes a microclimate. It means that when outside of the house, the temperature is about 40 to 50 degrees centigrade. In the courtyard, it is about 10 centigrade less. And when you go inside to the rooms, then the temperature is about between 25 to 30 degrees centigrade. And you have basement here also. When you go to the basement, usually you need to put a jacket. It means that if you go with your summer suit or summer clothes inside, probably you catch cold. It means that it's a passive system, actually, that it works very good and very comfortable. Well, in most of cities in Iran, even in Isfahan, even in Tehran, it used to be, they use the wind towers in some buildings, especially in hot, dry regions in the country, from the center to the south. As you can see, most of you are familiar with the functioning of a wind tower. It intakes the wind inside, then it circulates, and then when it becomes a bit warmer, it goes out from the other side, as you can see. Even this building is under construction in Yazd. Even at the moment, when you go inside, under the wind tower, you feel it's working and it's very cold and very pleasant. And there have been so many studies about behavior of this, and you need to do some CFD analysis, and it shows you that it works and it makes you comfortable inside the building. Even you can see here that it very depends on the direction of the wind. If the wind is the wind comes towards the wind tower at a degree of 45 at 45 degrees, it has the best performance. And when you have it in another inclinations or directions other than 45 degrees, its efficiency reduces. It means that even the direction of the building and the direction of the wind tower towards the dominant wind is a very important one. And in most of the buildings in the country, there has been a special direction for the wind towers that if it was in another direction, the efficiency would decrease. Even as you can see here, the height of the wind tower is important, and it's very interesting that if you use very high wind tower, its efficiency decrease. It means that it has an optimum height for each wind tower. Now we go to the last part of my presentation, which is about the characteristics of Persian Adobe, as you can see. Well, sometimes we have some restoration works, like here, as you can see. Here you have some cracks. How should we restore the crack? And here in the basement, there has been some sort of leakage of water a few years ago. How should we restore it? Should we restore it with new Adobe, with old Adobe, with which type of Adobe? Here now let's go there. We tried to do something. We said, okay, we try to do some tests on both old or original Adobe taken from the building, and also we made some new Adobe similar to old Adobe, and we did some tests. We should do different tests. One test, for example, is mechanical test, as you can see here. Okay, and even we try to use it in two situations, for dry and for wet Adobe, as you can see. Well, I don't want to go to mechanical issues, but if you have a look here, the one to the left on the top, it's the compressive strength. From A to G, these are old Adobe, original Adobe. And I, J, K, as you can see, these are new Adobe. We tried to use those new Adobe which are not very strong. But as you can see here, if you compare this new with old one, they are too much strong, that it means that it is not recommended to use old one, a new one. But here it's very interesting result. As you can see here, two types of Adobe have been taken from this basement. One, which is Adobe A, taken from dry side, and the other, which is E, is taken from the other side, which has been previously wet. At the moment, it is dry, but it was previously wet. As you can see, after wetting and drying, the compressive strength of the Adobe has increased And it is very interesting that it was our, because before that we were concerned about this part. We were concerned if the Adobe has lost its compressive strength, but interestingly, the result was something else. It means that there is not a general conclusion for Adobe, and for each specific project, specific calculations and specific studies should be done. Also, if you do some stress-strain analysis for old and new Adobe, again, you can see that the behavior somehow is the same, and that's it. Also, you need to do some petrography tests, because you need to, if you want to make new Adobe, it should be similar, and not only from the mechanical viewpoint, but also from a chemical viewpoint. It should be similar, and also you should make sure that the soil is the same. And as if I want to say something, that in Iran it is a tradition that if you want to make a house from Adobe, you should use the soil from the ground of the same site. It means that here the Adobe is taken from the soil of the house itself, and at the moment there is enough soil again in order to make new Adobe to be used in restoration. And now I go to the last one, that there are so many issues that could damage the Adobe. One of the main important is the water-related problems, wind erosion, vegetation, insects, vermin, and again, very important, material incompatibilities. For water-related problems, here, as you can see in the picture to the left, you have coving during the rain in the winter, and here also you might have moisture. But if you make an anti-moisture canal, you can resolve the problem easily. In order to protect the damage, the Adobe break should be repaired by patching with the Adobe similar to original fabric. It is very important to be similar. If you use mortar, the mortar should be similar to the original. Never use Portland cement, and also never use lime cement. For wooden elements, they should be replaced by wood, preferably by same wood. For coating, it should be the same material, not another or different material. For the roof, again, the repairing should be used or done with original form and with original materials. And floors, windows, doors should be preserved whenever possible. Never try to change them unless you have to. And as you can hear, again, here the picture on the bottom is the University of Art in Isfahan, as you can see. It is the Faculty of Restoration of Historical Buildings. As you can see, the building is a 4th century building, and every year they change the mud straw plaster. And as you can see here, is the method. Even this person could be one of the professors with his or her students. They make this mud straw. They do it by feet. They mix it, and then maybe they get some help from some other people, experienced people, to put the plaster on here. And it's very good educational effect on the students when they graduate from the faculty. They always keep it in mind that even we are in the 21st century, but still we can use the same that they used many, many years ago. In order to conclude, I should say that sustainable Adobe and Adobe construction has been a human tradition for millennia. Therefore, it's our duty to keep this tradition. It is important to keep the traditional methods of construction and to use traditional materials for the maintenance of Adobe buildings. And also, incompatible materials and methods should be avoided as much as possible. I should thank you for you, and let me a few minutes to explain about Persian Adobe heritage, and I'm ready to give any answer if there is any question. Thank you very much.
Thank you so much, Professor Mehrdad, for your lively presentation. You presented about the traditional preparation methods and building techniques of Adobe, and you stressed on this method as indispensable component for authentic reconstruction or restorations.